Okay, hi everyone. Welcome to Design with Ops in Mind. My name's Alex Livingstone. I'm a technical account manager with AWS.
Hello, my name is Liga. I am a technical account manager with AWS.
Her sound's not on. Try again.
Does it work now?
Yeah.
Perfect. Hello, my name is Liga. I am a technical account manager with AWS.
Okay, so in this session, we're going to take you through the deployment of a workload, but we're going to go through a few of the things you should do when before you deploy a workload into production, and how to do these as code, and basically apply the same kind of engineering principles you would do with your workload into how you deploy it, and making it easy for operations. So before we start, I kind of wanted to set the premise here. The purpose of software, basically any kind of software that you can think of, ultimately it is to help people. And I tried to think for ages and ages, is there any example I could think of that doesn't fit this? But I think it's safe to say that every example of software is to help people. So Airbnb, for example, they match people up with landlords to rent out properties. Ocado, they obviously deliver online groceries, and Sage help people and companies automate their accounting. So I really believe this is a powerful statement. Everybody in this room, in some way or another, is involved with software and is therefore involved with trying to help people to do something or achieve something. So ultimately, you should try and work backwards from the people you're helping. And this is where non-functional requirements are crucial. So there's no point in designing the best phone in the world if it spontaneously catches on fire. You can't take it on an aeroplane, and ultimately they recall every single one of them. So great phone, it's a bit of a shame. And whilst we're on the subject of phones, there are going to be some demos in this presentation. We pre-recorded them because it would be impossible to do them in real time, and so sequences may be shortened, and some of them are shortened by quite a lot. But it's still just to give you an overview of how these things work. And also, what we kind of want you to take away from this presentation is not all the individual details about how every single component works. It's about the principles of designing with operations in mind, and to get an idea of some of the kind of things you can do. So it's more about the end goal of designing with ops in mind and some of the possibilities. So don't try and remember everything. So when you're working backwards from the people you're trying to help, reliability is critical. People want reliable products at the end of the day. Maintainability. To provide a good product, you have to be able to maintain it. You have to be able to meet the demands of changing requirements. Could be changing business requirements, legal requirements, compliance requirements. The product has to be supportable. If you can't support the product, you can't maintain it, and you'll end up with a useless product. Obviously, the product has to be usable, so the end user has to be able to use the product. It has to be extensible. So when you have a product out in the market, people normally want product features to be added. And it has to be cost effective. Doesn't mean cheap, has to be cost effective.
The design of your workload should include how it will be deployed, tested, updated, and operated. Designing with ops in mind and having a well-defined process on launching your workloads makes operations easier and more effective. Deployment ties back to few operational outcomes that Alex just mentioned, like reliability, maintainability, supportability, and extensibility. The deployment should use a constant process across your environments in order to ensure that you are ready to go live. Testing ties back to operational outcomes like reliability and usability. Automate testing workloads. Ensure that there's an easy visibility if things are not functioning as they should. Change ties back to operational outcomes like reliability, maintainability, supportability, and extensibility. If you get deployment right, making a change becomes easier. It's basically redeploying updated workloads with already existing deployment methods. Monitoring ties back to operational outcomes like reliability and supportability. Ensure your workloads have built-in health checks that report on service availability throughout the stack. Logging ties back to operational outcomes like supportability and affordability. Ensure workload has sufficient logs and design with automated logging in mind. And tracing ties back to operational outcomes like reliability and supportability. Provide means to trace your workload. See interconnection and performance between all the different components.
Okay, so don't leave operations guessing. This is not what you want to have happen. So I'm sure we've all been in this situation, well, at least all of you kind of my age or older anyway. You know, in traditional IT, you had this separation of development and operations. And for some of you, that might still exist. Some of you might be in a DevOps environment. If you're in a DevOps environment, it's even worse because you don't want to be throwing yourself a curveball, right? That's a really bad situation to be in. So designing with ops in mind is about avoiding this scenario. So for deployment, you want to automate your workloads to avoid operational issues. And by automating the process, you try and eliminate human error. In fact, you do eliminate human error to a certain extent, unless you've got an error in your automation. For testing, you should automate your workload testing as much as you possibly can. It's probably the most difficult part to automate. For change, you should build change into your design. So you should design with the fact that you're going to have to change your workload in the future. And this is really important. And a lot of the time, you have an end goal of the feature sets you have to deliver. But people don't think about the fact that they have to change that workload at some point in the future. Monitoring. So design your workload so that you can give operations a good idea of what's happening, or if something's gone wrong, what has happened. And we'll talk about more of all of these things. And the same goes for logging and for tracing as well.
If I look back at my operations experience, I can remember a few occasions when I would get involved in the deployment of a new product quite late in the stage. So it has already been developed, and the operations would basically get a link to the deployment artifact from developers. And then it would be our job to kind of deploy it throughout different environments and make sure that things work as they should. And sometimes we would get some like documentation and requirements, but often there would be not so much details provided, so we would be going back and forth trying to get more information from developers to make sure that everything works as expected. And to avoid this situation, you should think about design for deployment already when you are designing your application. First, treat your infrastructure as a code. Build and rebuild your resources in a safe manner without manual interaction. And AWS CloudFormation provides a common language that you can use to provision all the infrastructure for your cloud environment. Use shared design standards. Approved and hardened applications throughout different environments. AWS Service Catalog allows you to centrally manage commonly used IT services and enabling users to find and deploy only the approved IT services they require. Version control. It enables you to track the changes between environments. It allows you to have a faster development and deployment lifecycle. AWS Code Commit is a fully managed source control service that makes it easy for companies to host secure and highly available Git repositories. Automated deployments. Design your workloads to support automated deployments so you can deploy reliably and rapidly across different environments. AWS Code Deploy is a service that automates software deployment to different compute services, including Amazon EC2, AWS Lambda, and services running on-premise. Design your workloads to support continuous delivery and continuous integration. And here we have a service called AWS Code Pipeline that that supports continuous integration and continuous delivery. So it basically builds, tests, and deploys your code as per the release process that you define. And next, I would like to show you a demo of CloudFormation and Code Commit. And as Alex already mentioned, it will be a pre-recorded one. So first, we'll go to CloudFormation console. And here are several options, but I want to quickly show you the designer. This basically allows you to visualize your CloudFormation resources and see how they are connected. So we are uploading an existing CloudFormation template that we have prepared for this demo. And now you can see all the different components that, that we are going to deploy. And you can also inspect individual components and even go and see how they are defined within the CloudFormation and do changes if you so decide. What we are going to do next is actually go back and create a CloudFormation stack. So we go back to CloudFormation console and choose to create a stack. And again, we are uploading a template that I just showed you with the designer. And in the next step, we can set parameters. And you can use parameters to ensure that you do not need to hard code any variables in your template. So you can set them up in the creation time. And we are just adding all the necessary details that the template requires. And afterwards, we just review on what resources are going to be created. And we also have to acknowledge that there might be some IAM resources that get created. And now you can see that the CloudFormation resource creation is in process, and you can inspect the events and see how they get updated and what resources get created. And now the creation is complete. We go to AWS Code Commit console here, and we just the CloudFormation stack that we just deployed created a repository, but this repository is empty. So what we are going to do actually now is we are going to our local machine and we will clone the repository. And then we copy our code there, and we can use the standard Git tools to add and commit code to the repository. And then if we go back to the code commit console, you will see that the code has been committed there. And you can also see the history of commits. At the moment, we have just one. So you can see what time the commit was done and by whom. And there is also an option to visualize the commits. At the moment, it's just the initial commit, so there's only one.
So actually, before I go on to design for testing, one thing that I've forgotten to put in that slide, is once you've got infrastructure as code, then you've got all the benefits of all the tools you can use for coding, such as version control for your infrastructure. So just bear that in mind as well. That can make infrastructure a lot easier. So I'm thinking back now to a time a while ago where I was involved in this really big software project, and it wasn't designed for testing, and it made testing really, really difficult. It wasn't designed for testing. It certainly wasn't designed for automated testing. And that meant whenever we did a release, the devs had to test it, operations has to test it, and then the business had to test it. And it took days, if not weeks, to go from the stage where we were ready to deploy and to go through testing and actually deploy it. And this was a really painful experience, and actually it became so unsustainable that the project got cancelled largely because of that. So you should use continuous delivery to quickly enable you to deploy your workloads, but also automate your testing as well. And you can use code pipeline to do this. So if you automate your testing, along with some of these other tools, it allows you to automate fully your complete pipeline. And this includes things such as unit testing, so to isolate each part of your workload so that it functions correctly, integration testing, functional testing, stress testing, performance testing, and usability testing. Unit testing might be the easiest ones of those to automate, but ideally you want to be able to automate all of those tests. Also, try and utilize synthetic transactions. So synthetic transactions allow you to test for operational outcomes. So say I've got an e-commerce site, I could create a synthetic transaction to do a test purchase, and I expect the purchase to take no longer than 1 second, because that's what the business has said is acceptable. If it takes longer than a second, we know we've got a problem. We could choose not to deploy, or we could inform the business, do you want to continue based on the results of this test? And then integrate deep pings and health checks into your workload. So we have elastic load balancers, which I'm sure a lot of you are probably aware of. You can health check your EC2 instances behind those load balancers. Now you can do something simple like have a page that just responds, and if it responds with a 200 response, then great, everything's running. The trouble is with that, if your web server is reliant upon, say, a database server, then if your connectivity to that database server is not available, or the database server itself is not available, your web server is still saying it's working. So try and make those health checks at least 2 deep, so you're going and checking your dependencies as well. That way, if the database server is down, or you lose connectivity from your web server to the database server, that EC2 instance would be taken out of the load balancer, and it would be replaced if it was in an appropriate auto-scaling group. So again, another pre-recorded demo. These would take way too long if we didn't pre-record them. So this is code pipeline. So we're going to look at the CloudFormation template that we created earlier. And I'm going to look at the outputs from the CloudFormation template. And you can see here that a code pipeline URL is one of the outputs. So this is code pipeline. And you can see we've already committed the source code, but we've got a failure here on a task called validate runbook. So this is checking, has my runbook been updated in the last 4 hours before I've done the deployment? And it hasn't. So we're going to go and edit the runbook. So I'm just adding another step here. And this check is done using a Lambda. So I save the changes, and then I can go back to code pipeline, and then I can retry that stage in code pipeline, and it will continue through the code pipeline. So it's going to reinvoke that Lambda function, check that the runbook's been updated. Then it's going to use AWS code build to build my, in this case, it's a Go application. And then it goes through to staging, where it's going to deploy infrastructure using CloudFormation again. Then it's going to use AWS code deploy to deploy the code that I've built into the infrastructure that I've built. And then we're going to use Lambda again to run a synthetic transaction. And it's failed. Planned failure, this one. So I don't know if you can make it out, but it's because there's a latency breach. And this is because we've purposefully written a loop to simulate CPU work. So we've purposefully introduced latency. So I've just reduced that loop, and then we're going to recommit this code and push it back to code commit. You see that code commit automatically picks it up, and then it runs through the pipeline again. Obviously, this is sped up. It's going through the build, goes back to staging again, redeploys the code, and then does a synthetic transaction test again, and this time it passes. And we've put a manual approval gate in here. You don't have to do this, but we've done it here. And you just put a reason to approve or reject. We approve it, and then we go through to production. And it does the same thing. And here I've gone through this very quickly, get the load balancer, get the URL, and here you can just see that it's working.
So again, if I look back at my operations experience, I had the pleasure to be on call for quite a long time. And I still remember these late nights when I would be sleeping and I would be waken up by a page. And then I would try to kind of go through the alerts and logs and different services just to understand what is not working. And it is no fun to do that in the middle of the night and when you do not have colleagues that you can ask and get help from. So think about monitoring already at the design stage. Is the application doing what it is supposed to do and in a timely fashion? Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications you run on AWS. Also, look into operational and security trends, changes made to your workloads and applications on a regular basis. With AWS CloudTrail, you can discover and troubleshoot security and operational issues by capturing a comprehensive history of changes that occurred within your environment. Designed for centralized monitoring, it is a waste of time to log on to different servers to see the trends. When it comes to custom CloudWatch metrics, work backwards from what you want the outcome to be. So let's say if you want the page load time to be below 1 second, provide the tools to actually see this within your workload. And also developers know the application the best. So they should ensure that they help operation teams by providing health checks and visibility on how the application is performing. Also, think about what would be a good metric to scale your application on. Often infrastructure metrics like CPU and memory is not the answer here. So you can use the custom CloudWatch metrics to design a scaling metric that works for your application. And monitoring is essential to operations to discover that something has gone wrong. And the more details you provide, the easier it will be for the operations to resolve the issues.
So again, another short story, but this is going back a few years. But I remember writing a root cause analysis document. I'm sure a lot of people have done that for an outage on a massive e-commerce platform. And unfortunately, we had hardware logs, we had application logs, we had networking logs, but they were all in different places. Application logs weren't centralized, so we had to log on to every single application server to get those. And actually finding the root cause analysis of this problem was a nightmare. Had to get all the logs, get them all together, put them into a spreadsheet, and then to make it even worse, we had 2 NTP services, and they were out of sync with each other because one was pointing to a time service that didn't exist anymore. So it was a complete nightmare. So in the end, it turned out it was an application issue, but it took looking at the infrastructure logs to find out that it was an application issue. And the key here is to centralize your logging. And to do that, you can use Amazon CloudWatch. And again, for auditing, you can use AWS CloudTrail. And centralizing your logs, it makes it much easier to identify the root cause of an issue. If you can look at all of your application logs, all of your infrastructure logs, networking logs, DNS logs, all in one place, all with one search, it makes it a lot easier. So that's the key first thing, centralize your logging platform. And store the workload and infrastructure logs together. It's so much easier when you can see what the application is doing and what the infrastructure is doing in the same place. So in AWS, you can use vended logs, we call them, for VPC flow logs. These are essentially your networking logs, and Route 53 for your DNS logs. So you can have your workload logs, infrastructure logs, networking logs, and DNS logs all in one place in CloudWatch logs. And again, try and reinforce this amongst the development teams, especially for workload logs. If you can find a way to get key logging information from your application straight into something like Amazon CloudWatch, so you've got all your logs in one place, it makes it much easier. And this provides vital information for operations and for the development teams to look at the root cause for issues. So I'm going to, again, another pre-recorded demo of CloudWatch. So I've got a production instance here from what we created earlier, and I'm just going to kill it. Then I'm going to go back to CloudWatch. I've got an alarm here that tells me if I've got less than 2 production instances running. I'm looking at the details. At the bottom there, you should be able to see that it sends an SNS alert to, and this SNS alert is using a Lambda function called log demo. And all that does is create a log in a CloudWatch log stream. Now, in the real world, that's not going to be much use, but this is just giving you an idea of what's possible. So here's my log. And this is the latest event in that log. So this is just saying I had an alert and I'm logging the alert. Not very useful, but you can do a lot more useful things than this. So again, I'm going to go back into the CloudWatch console. And this time I'm going to show you how you can create metrics from logs. So in this particular application, in the synthetic transaction, we were measuring latency to see whether it was acceptable to put into production. So here I'm going to filter the log events because I know there's one for time. And it's not a great way of displaying it. There's no way you could use this as a metric at the moment. But what you can do is create a metric filter. So I've already set one up here. And this is how it's created. You create a filter pattern, and you can show the results based on some test logs. And then you can assign these as variables. So I'm just interested in latency. So I'm creating latency as a variable. And that place, you can see the example latencies. And then I'm going to show you dashboards. So we pre-created a dashboard for this. And in that dashboard, you can see latency there. So that latency after staging is where we're running that synthetic transaction test. And this is production. And this is where we don't have the latency issue. I refreshed a few times to avoid DNS, to make it cache DNS. And here you can see in the bottom right, there's timing in milliseconds there for staging before and after we corrected the error. So it was about 600 milliseconds. It went down to a couple of hundred. And you can see that reflected in the graph. And also you can see when you move along the graph in a CloudWatch dashboard, you can see it also reflects on the other graphs as well. So you can easily compare, in this example, a spike in CPU on staging with the latency after staging graph. And you can add thresholds there, so you can see anything above red is bad, and that's where we're saying we don't want to go into production if we've got that issue.
An example again of a thing that maybe is one of my least things to debug is when you actually get some kind of request and complaint from a user that a request is failing sometimes. So what you do is going and logging on to different services, checking log files, testing the connection between different components manually. And it takes a lot of time and effort. So instead, you should design your application with tracing in mind. So it enables an end-to-end view of how your application is performing. And we have an AWS X-ray service that helps to analyze and debug production distributed applications, especially those built with microservices architecture. So with X-ray, you can build and trace your workloads, and you can understand how applications are performing. And as X-ray is providing this end-to-end view of your request, it also shows a map of your application and all the components and how they are connected. And you can discover applicational issues, like find out what the latency is, and you can follow the request path to pinpoint to which particular service is causing a problem. It provides a good overview for the operations to be more proactive and discover issues faster. And it's time for another demo, and I want to show you how X-ray works. So first we go to an X-ray console, and we will see a very simple service map here of the service that Alex was deploying with Code Pipeline before. But still you can inspect the request and kind of go to an individual trace and see how the request is performing. But this is not much insight, so what we will do is we will actually create a sample application here that you can also do if you want to test how X-ray works. And it is using CloudFormation template, so I will not go more into details here, but again, we are specifying some parameters that are required to create this application. So now the CloudFormation stack has been completed, and you can also see all the resources that it created. Next, we will go to an EC2 console. As part of this CloudFormation stack, there was an EC2 instance created, and this instance is basically helping us to generate some sample requests. So we just go and find the public endpoint of the instance, so we can go and generate some sample requests that we can later inspect with the X-ray console. So all we need to do here is basically just start the application, and it will generate some logs and requests. So now if I go back to the service map, you will see that there are more details here. You can see that we have an instance created, we have a DynamoDB, and we have an SNS topic. And you can see this green circle with a little bit of yellow there in some cases. It basically shows the successful requests against failed requests and errors. And you can also see the average latency or request time. And then you can go and inspect an individual request and trace it through different services and components. So we can look at DynamoDB there and then SNS topic. And it also provides you raw data of your request.
So when we say you can try that for yourself, by the way, if you go to the X-ray console and click Getting Started, it basically produces what we've just shown you. So I'm going to talk, excuse me, I'm going to talk about checklists, but I want to mention Lambda. We've used it a few times already in a couple of the demos. So Lambda automatically runs your code as serverless functions. So you don't have to manage any infrastructure. And it's useful for a whole bunch of things. It can be useful for your applications or to code your applications in, but it's really, really extremely useful in operations. So we've used it, for example, to check if the runbook had been updated. We also used it to do the synthetic transaction. And it can also be used, so CloudWatch events or CloudWatch alarms can be used to trigger Lambdas to produce automated responses, such as runbooks or playbooks. So the key thing is first, use operational checklists. So you can automate some of this with AWS Code Pipeline, as we showed you. You can automate security evaluations with Amazon Inspector. And you can automate compliance checks with AWS Config. We haven't got time to go into how all of these things work and exactly what they do, but these things can all help you automate this and remove some of the barriers that you may have to getting things into production, some of the gates, basically. If you automate as much as possible and you have pre-approved changes, and these are involved in your pre-approved changes, you can get rid of those gates, and it should ease your path to production. And this is one I'm particularly passionate about. Checks outside the system. So staffing. So do you have the capacity? Do you have enough people for when you've deployed your application to support it? Do you have the capability? Do you have the availability? I've been in situations where the business have said, here, deploy this into production. It's got to be up 24/7. Yeah, but we don't have any people that are employed to respond out of hours. I'm sure some of you might have been there before. And then, are these people in the right location? So, runbooks. Do you have well-defined procedures for well-known scenarios? And these could be manual or automated. Ideally, you want them automated. There's nothing wrong with having them manual at first and then try to automate them. And playbooks. Do you have well-designed procedures for unknown events? Equally important. And these could start off as something like, something's gone wrong, we don't know what it is, we'll call Dave. That could be your playbook to start with. And documentation, obviously. So this should include requirements, so the business requirements. You need to know what the application is supposed to do. Design, architecture, testing, maintenance, operations, and end-user documentation.
So in traditional IT, a change can take a long time. So you would create a change request, you would get it approved, then you would find somebody to actually implement the change, and then you would test it. And if things didn't work as expected, you would kind of be back to the square one. And software is not static. It is improved as per feedback from users and monitoring systems. And when designing your workloads, you should think about how change will affect your application. AWS CloudFormation change sets enables you to see how changes will affect running resources before you actually implement the change, so you can update workloads with confidence. When you create a change set, it enables you to see what updates will be made to the system, And you can also use this information for documentation, for example, to automate documentation. And because you have all the documentation around what resources will be affected, you can also build in an approval process if it is required, for example, for production database updates. And also you can do an automatic rollback for non-destructive changes. And we'll look at example of replacing standalone web server with an auto-scaling group and a load balancer. So with CloudFormation change set, you would have the original stack that created the web server, and then you would create a change set where you would create auto-scaling group and auto-scaling launch configuration, and you would create a load balancer, and then you would remove the instance. So you can view the change set. And as an example for the change that I just mentioned, here you would see that there would be an auto-scaling group and launch configuration added, and then also a load balancer, and the instance would get removed. So you can preview this before you actually execute any changes. And you can also use this for documentation, or if you require an approval process around this. And afterwards, what you can do is you can either create additional change sets. So for example, if something there didn't look right, you can create an additional change set just to see how changing the infrastructure in other way would affect underlying resources. Or if you're happy with it, you can execute the change set, and CloudFormation will update your stack and resources.
So patching, I'm sure it's everyone's favorite topic. So patching is obviously essential for operations. And in most cases, it's going to either be enforced by the business as a policy, or because of the technology choice you've made. But patching solves problems, so it's important. It obviously solves security vulnerabilities, but also operating system or application stability, or it fixes a bug. And this comes back to working backwards from the people you're trying to help in the first place. And it comes back to reliability. Patched software is more reliable, or patched operating systems. It's more maintainable, more supportable, and more usable. And patching is not easy. You need to think about things like automation, maintenance windows, dependencies, frequency. And your patching strategy, are you going to patch running servers, or are you going to replace them with a whole bunch of new servers with a blue-green deployment or something? So design your workloads so that infrastructure can be patched, and design for maintenance windows and automate it as much as possible. And you can use AWS Systems Manager to do some of this automation. And you can use Amazon Inspector for security compliance. And this is an example of, well, it's a diagram of how you can automatically patch, in this instance, an AMI. So what Systems Manager does is it executes an automation. And this is called an automation document. And automation document is just a set of instructions that the Systems Manager follows. And we have a load of predefined automation documents. And for this example, it would be one of two. It would be update Windows AMI or update Linux AMI. And what it would do is it would launch a temporary instance based on your existing AMI. It would optionally run a startup script that you provided. It would then update AWS tools, update any distribution packages, and then optionally run a shutdown script as well. And after that, you get your patched AMI.
I just quickly want to touch other operational design considerations apart of the things we already discussed, like deployment, change, testing, monitoring, and so on. So first being security, what are your compliance requirements? Design with least privileged access in mind. Reliability and high availability. What is your recovery time and point objective? Think about multi-AZ deployments or regional failover. Design for performance. Keep up with change in demand and technology when designing your workloads. How easy it is to scale and how easy it is to replace a particular component. And design for cost optimization. Right-size your instances, consider reserved instances, also monitor around spend. And just briefly to touch on data management, when you design your application, you should think about what is your data lifecycle. So when can you actually move your data to archiving or Glacier in case of Amazon S3 storage? Or when can the data be deleted? It's much easier to get this right during the design stage than do it later on.
Okay, so hopefully, if you do all of these things, you shouldn't be woken up in the middle of the night. Okay, it might happen occasionally, but it should happen less. There should be less, you know, those moments where you or somebody else in your team, they magically pull a rabbit out of a hat, and you think, how the hell did we manage to fix that? And overall, you should just have less pain. So if you take anything away from this, it's design with operations in mind. When you're designing your workloads, make sure that you're thinking about how operations are going to manage that workload once it's put into production. And then you should be able to do more sleeping. So please, everyone, fill in the survey. We really appreciate any feedback. And come see Liga and myself. We'll be in the operating and optimizing area outside in the Ready for Anything booth. And yeah, thank you very much.
Thank you.